the next thing we need to learn how to do is to be able to spot and then model a quadratic sequence or a table of values that is created by a quadratic type function. Now remember, quadratic means a function that can be written as ax squared plus bx plus c. Now this particular sequence of numbers can be put into a table, and then we can look at first and then second differences to see that this list of values was created by a quadratic function. Now since the list of values is being given to you in this order, then we will assume that an x value of 1 is what gave you the y value of 26, an x value of 2 gave the 13, an x value of 3 gave the 6, an x value of 4 gave the 5, 5 gave 10, 6 gave 21, and then 7 gave 38. Now you can see that the change in x here is 1 each time. Therefore, all we have to really pay attention to was the change in y. Now, as we look at that, we notice that 13 minus 26 is a change of negative 13. 6 minus 13 is a change of negative 7. 5 take away 6 is a change of negative 1. 10 from 5 is a change of 5. 10 to 21 is a change of 11. And 21 to 38 is a change of 19. Now, we know that this isn't a linear relationship because these are different, and therefore their ratios would be different. But if we look, we see that 7 take away negative 13 is a change of 6. Negative 1 take away 7 is a change of 6. 5 take away negative 1 is a change of 6. 11 take away 5 is a change of 6. And 19 take away 11 is, if I subtracted right, oops, sorry, that should have been, 17. That's why it was messing up on me. 17 take away 11 is a change of 6 because I subtracted wrong right there. Now this is how we know we have a quadratic relationship. These would all match if it was linear. These will match because it is in fact quadratic. So that's the easiest way to spot that that is the type of relationship you have. Now we have another one set up here. If you look at the smart view image of the calculator, we have some y values here, a 2, a 1, a 8, a 23, a 46, and so on. And we could copy those down into a table with our x's and y's again. Now notice these x's started at 0. So we had 0, 1, 2, 3, 4, 5, and 6. Our y's were 2, 1, 8, 2, 1, 8, and then 23, 46, 77, 23, 46, 77, and our last number was 116. So, this is a difference of negative 1, this is a difference of 7, this is a difference of 15, this is a difference of 23, and just sort of stopping there to look, we can go on. 7 take away negative 1 is a difference of 8. 15 take away 7 is a difference of 8. 23 take away 15 is a difference of 8. So we've identified it because the second difference matches as a quadratic. Now that we know how to tell whether a sequence of numbers or a table of values can be modeled by a quadratic or not, let's see how you can go about finding the quadratic function, the quadratic equation, or the quadratic rule, whatever you want to call it, that gave you that list of numbers. Now, one of the lists of numbers is already in the calculator. That's actually where I got this one from. I could just hit the y equal to and see what the rule was that gave me that list of numbers, but we're going to find it. Now, there are ways to do it by hand, but I really think the most sophisticated way to do it is on the calculator. So there's our list of numbers. First of all, our x values. We'll go to the stat editor and put in 0, 1, 2, 3, 4, 5, and 6. And again, remember, those were our x values. Now our y values, we'll put those in next, back in the editors. Remember, they're actually written down over here. It was 2, 1, 8. We'll put those in first. 2, enter. 1, enter. 8, enter. And the next one was 23, 46, 77. So we'll put in 23, 46, 77. And that last one was 116. Alright, now that the numbers are all in place, hit the Stat menu. This time we go over to Calculations. If we were trying to use a straight line to hit all of those values, we do a linear regression. But actually we know it's quadratic because we've observed that the second difference matches. So we'll hit number 5 for quadratic regression. And it says that the rule that gave us those values is 4x squared minus 5x plus 2. And when we hit the y equal 2 button, we see that that is exactly what the rule was that gave those values. So when you have a table of values or a sequence of values that you can then put into a table, then you can figure out that it's quadratic by finding that the second difference is common, or it's called a second common difference. Once you know that it's quadratic, you can put the x and y values into the TI calculator, and it will give you the rule that will give those inputs and outputs.